The topic that we're going to talk today about is 3D equilibrium of particle. Again, when we talk about particle, meaning that we have an object that doesn't have dimension. So basically, we are talking about one point. At one point, we like to see the sum of forces are zero. Or basically, because it's a three-dimensional, what we can say sum of f of x equal to zero, sum of f of y equal to zero, and sum of f of z equal to zero. Now, basically, in a vector approach, you can just simply say f1 plus f2 plus f3 plus w is equal to 0. Again, if I have a diagram like this, which I have a weight connected at point A, so you can see at point A as one point of particle. At that point, I have three forces, force F1, F2, and F3, and then I have W. So what I could say sum of F is equal to 0. So F1 plus F2 plus F3 plus W equal to 0. Just remember, look at the arrow on the top. This is important. We are not simply adding the forces. We are adding them with their directions. So that's why F1 should be in terms of F1 xi, F1 y, and then F1 zk. Same thing with F2, and then similarly for F3. Now what we could do, we could simply say sum of I, sum of j, and sum of k equal to 0. We have three equations, and then we can have three unknowns in 3D equilibrium of a particle. Let's just look at one example and then see how can we solve that example. In this given example, there's a 150-pound crate. It's supported at point A. As you can see the diagram, you can see point A is supported with three cables. One cable is going from A to C, the other cable is going from A to D, and then the third cable is going from A to B. So three cables holding the object upward. We can go with the same approach that we talk. So basically we need to find this summation of equation and ended up at sum of I, sum of j, and sum of k. So in the first step, what I'm going to do, I'm going to bring the forces like AD, AC, and AB. I need to bring these forces to find their IJK component. So the basic way is that I'm going to find the coordinate of each of these points. Point A is at 6, 0, 0. Again, remember x is on this side, y in this side, and z in this side. Point C is at 0 on the x, minus 2 on the y, and 3 on the z. Same thing for point B. So what I could do, I could start doing the position vector. If you remember what we talked in the beginning of the semester, where we like to convert a force that where we have the coordinates and find the resultant force for those. You remember we used the method called the unit vector. So what I'm going to do, I'm going to find, again, the first step, you find the coordinate. That's what we did here. The coordinate of A, B, and C. The second step is to find the U of each of them. UAB, UAC, and UAD. So in order to find the U of them, what I could say AB is equal to B minus A. And then AC is equal to C minus A. AD is equal to D minus A. Once I did this, I would end up at the equations that you can see them here. Again, going from a vector to its unit vector, you just divide it by its length. And then to find the length, for instance, minus 6, 3, and 2, B minus A is this much. So B minus A, we have 0, minus 6, it will be minus 6, 3 minus 0, and then 2 minus 0, which is going to be 3 and 2. The length of this vector is root square of 6 to the power of 2, 3 to the power of 2, plus 2 to the power of 2. On the top, you can put minus 6i plus 3j plus 2k. Then, actually, the denominator is simply 7. I'm going to do the same thing for AC. Again, remember, the force is going from A to C, from A to B, and from A to D. For AB, we repeat that. For AC is minus 6 minus 2 plus 3. And then for AD, basically AD is a little bit tricky because we don't have a coordinate of another point. But the thing that we have, A and D, both of them are on the x-axis. You don't need to do anything. That's just simply I. That's in the direction of I. And that's actually, I can say U for AD is simply I plus 0j plus 0k. Now, in the second step, what we do, we don't know FAB, we don't know FAC, we don't know FAD, and then the 50. Remember, that what we could say in the equation, we could say FAB plus FAC plus FAD plus W is 0. So this plus this plus this is equal to 0 in vector, right? The summation of those will be 0. So whatever u we got in this direction, again, we simplify that. 6 divided by 7 is 0.857. 3 divided by 7 is 429. 2 divided by 7 is 0.286. Now, what I'm going to do, I'm going to multiply each of them by their unknown. In this case, we don't know how much FAB, FAC, and FAD is. But I know the weight of the crate is 150 pounds. So what I'm going to do, I'm going to put them together. But remember, for the weight, the direction of the weight is downward. In this case, the direction is downward. It simply is minus K. That's where the direction of the weight is. So I can say FAB multiplied by the UAB, and then FAC multiplied by UAC, FAD multiplied by UAD. Then I would get my equations here. So for FAB, I have 0.857 multiplied by FAB. We don't know how much the FAB is. Actually, we're looking for its magnitude. Then we repeat the same thing for FAC, repeat the third line for FAD. And then for W, we multiply this by 150, which is 0, 0, and minus 150. Now I can set up my equations. If this object wants to be in equilibrium, the sum of I, the sum of J, and the sum of AK should be 0. So on the I, we have minus 0.587 FAB, minus 0.857 FAC, plus FAD, plus 0 is equal to 0. That's what we did here. First, this equation is about sum of I. We're going to do the same thing for sum of J. Sum of J is 429 minus 0.286, and then plus 0 is equal to 0. The third equation is 0.286 and then 0.429 for FAC minus 150 for the W. Now you can see we have a setup of 3 equations and 3 unknowns. We can solve them manually, or we can use Octave Online and MATLAB. That's what we did for the other experiments. In MATLAB, if you want to solve a 3 unknowns, 3 equations, you can say AX is equal to B. A is the matrix of coefficient. In this case, the matrix of coefficient for FAB, or this again, the first 3 numbers are for your first unknown. This is for FAB. This is for the second unknown, which is FAC. And the last one is for FAD. The B is the right side. If you move the 150 to the other side, so minus 150 will be 150. Now we move on to Octave Online. We're going to put A is equal to this, B is equal to this, and then X is equal to inverse A times B. You can actually put A backslash B as well. It gives you the same result. And then once I got my result, I know the first one is for FAB, the second one is for FAC, and the last one is for FAD. Let's do another example like very similar to this. Again, this example is an example where I have a point D. At point D, I have 3 cables and a bucket. Very similar to the problem that we observed before. I need to find the coordinate for each point. Coordinate of point D is 3, 2, minus 2. Coordinate of point C, B, and A. Then if you look at the diagram is very important because it talks to us. You can see FDC, FDB, FDA plus W should be 0. The summation of these 4 forces in a vector approach should be 0. We repeat the same approach to find the FDA. First thing I do is I get dA is equal to A minus D is always again N minus the start. And dB is B minus D, and last one DC is C minus D. Then once you found these 3, you are moving to their unit vector. Unit vector is the vector divided by its length. Because again, we want to bring all of them to the same page, I'm going to put 5i minus 2j plus 2k divided by root square of 5 to the power of 2 plus 2 to the power of 2 plus 2 to the power of 2. And that's actually root of 33. We repeat the same thing for dB and dC. And the U of W is simply minus K. Same thing as we had on the top. So I'm going to multiply each of them by their unknowns. Again, right now I'm just actually going further with one step. On that step is in the first equation, you're going to have for FDA, we have root square of, again, everything on the top will be multiplied by FDA, everything in the middle by FDB, at the bottom by FDC, and then we can set up our equation for sum of I, sum of J, and sum of K. Again, we did it a little bit lazy this time, right? If you look at the up there, we were actually open it up like this, and we put FAB is equal to that equation. You could do the same thing here. We already know that this is what we are talking about. This is FDA is equal to this. Now we have the three equations, so we write the three equations, and then I'm going to moving the 20 from this side to the other side for the sum of K. On the K, you have 2 over root 33 FDA, 2 over root 17 FDB, 2 over root 38 FDC, minus 20 equal to 0. You bring the 20 to the other side. Now I'm going to go through again octave online and have the fun. So I create the matrix of the coefficient, and then matrix of coefficient is A. The noun side, the other side, is 0, 0, 20. And we put that on the code on the program, which is like A is equal to this, B is equal to this, and X is equal to inverse A times B, and this is gives us the answer. Thank you for watching this short